Let's round out this set of examples on solving exponential equations, looking at one where we get an exponential equation that is of quadratic type. If you notice, 49 in that first term, 49 to the x, 49 is equal to 7 squared. And we're seeing a 7 raised to a power in the second term. When you've got exponents right next to each other, we would multiply those to give us 2x as our first exponent of 7. However, I'm going to write it this way. The order of the multiplication would not matter. So 2 times x is the same as x times 2. Now we're seeing that we've got a 7x to the first power over here and a 7x to the second power here, telling me that we've got something of quadratic type. And so if we move the -3, we can factor. For some people, it's easier to see when we have something of quadratic type, use u substitution. Let u equal 7x. That turns the equation into this. Move the 3 to the other side. Factor. Set each factor equal to 0. And solve for u. But then what was u? We're supposed to be solving for x. And so we have to go back to how we define u in terms of x. Now the range of y equals 7 to the x is y values that are greater than 0, y values that are positive. So we should reject the second case, and I will give you another way of looking at that shortly, but that would be the first reason I would give. So we should only have 7 to the x equals 3. And if we take the natural log of both sides there, then apply the power rule, bringing the x out in front. Whatever natural log of 7 is, it's just a number. So x times some number. To get x alone, you would divide both sides by that number, natural log of 7. So I'm going to get a decimal approximation for that and check it in the original equation. 49 to the x minus 2 times 7 to the x should equal 3. So natural log of 3 over natural log of 7. What I showed previously would be an exact answer. Here's an approximate answer, which usually would either get rounded to 3 places or 4 places. If I take it to 3 places, 49 to the power 0.565 minus 2 times 7 to the 0.565. Then when I would go 3 places out, that would round to 3.00, well, 3.010. Now, if I took the natural log of 3 over natural log of 7 to 4 places, then that would round to 0.5646. And minus 2 times that. Okay, so 0.5646. Let's see if we're getting even closer to 3. When we round that to 4 places now that I've rounded natural log of 3 to natural divided by natural log of 7 to 4 places, now when I round this to 4 places, I'm getting 3.0006 even closer to 3. Now also, if I had not recognized that we should be rejecting the case where 7 to the x equals -1, well then, if I proceeded in the same way I did here, that would have resulted in natural log of -1 over natural log of 7. And at that point, you should go, well, I can't take the logarithm of a negative number. But say you still aren't remembering that. So you put it in. Oop. Natural log of 7. And it's giving me an error. So any way you look at it, we only take natural log of 3 over natural log of 7. We're rejecting this other case. And if I haven't already said it, when it comes to these solving of exponential equations, I hope these examples are helping. And I've got some more coming up on solving logarithmic equations. But I will say for now, hope this helps. Like the videos, subscribe to the channel, and share with anyone you know that needs some help on similar material. Take care, stay healthy, see you in the next one.